Let's talk about abstract classes. Well, abstract classes are classes that cannot, I repeat, cannot be instantiated on their own, right? So what can you do then? Well, you can have an abstract class that is the parent of another class, which you get to instantiate. And that itself, that class, which is the child class, will need to implement any methods that are abstract in that abstract class. So we'll do an example and we'll get right to this. But just remember, the main idea here is that the abstract class cannot be instantiated. So it's kind of similar, sort of, to the interface or interfaces, in the way that you have contracts, which basically say that, hey, if you have an abstract method or abstract methods in the abstract class, the concrete classes which extend that abstract class, they must implement those methods. Let's get an example going and we'll see exactly what that means. So I'll do the traditional example here, which I think makes sense because it's easy to visualize the concept. Imagine that you have a shape class. And the shape class would look something like this, where you can generate, let's say, and get or calculate area method. And I'm not going to pass anything to it, but you get the idea. You can pass certain things to it, the width, the height, depending on what it is. I'm just going to leave that empty, but just say that it will be public and it will return, let's just say, a float and whatever. It will return something, and here we'll leave it an abstract class. Abstract class like this. And it will return, what did I just do here? Abstract is, sorry, this will have to be public abstract class shape, and that's what I meant to do. Here, let's just say abstract, and that's exactly what I meant to do. So this will be an abstract method. That means that it's kind of similar to interfaces in that you could have a method like this, which doesn't have a body. There's no implementation to it. Notice that in the abstract class, you have to say abstract right before the method, right? Abstract public float, calculate area. And you must have this abstract keyword right before class. So imagine now that we have a circle class, and you can imagine that, well, you could have circle, rectangle, we could have a square, we could have a triangle, so on and so forth. I'm going to keep it simple for this video, but just know that circle is going to extend from shape, and what that means is that we'll have to implement these methods. Which method? Well, the calculate area method. This will do something like this, where you'll need some calculation. It's going to return 0 because it just did that for me. It's going to return some float, but you can enter the body of this will be the body of the method. Whatever the calculation is, you could do it here for the circle, which we know for a circle there's a formula for that, just like there's a formula for square, formula for a rectangle, formula for triangle, and so on and so forth. But shape itself, as you can imagine, it doesn't make sense for shape to be instantiated. Why? Because we don't know what a shape would look like. So why create, or the concept of creating a shape doesn't make sense because we don't know what it is. So this is an abstract class, right? Because we don't want shape to ever be instantiated. We want circle to be instantiated. So yeah, sure, that's fine. Just make sure that the developers or ourselves, we can go ahead and implement this method in the body of the method. So that's the main idea behind this right here. And if we were to run this and say, let's just create a circle. Let's just say my shape. This is going to be a circle. And it's going to be my shape. It's going to equal a new circle, and again we can just say system.out.println go ahead and print my shape dot notation, calculate the area, and we know that's going to be just 0 because we don't have anything going for there. But we know that we could just go ahead and implement that. I just want to show you that this is the main idea for just returning 0, but we know that my shape is a circle, so sure, my shape is a circle. My shape is a circle, and it does return 0. It's up to us to go ahead and make this, implement something that makes sense here. But the idea, though, is that we don't ever want to create shape. And just to prove that, imagine that we did something here like this. Like, go ahead and create a new shape. Well, you know the IDE is already telling us at compile time that shape is abstract. It could not be instantiated. And furthermore, if we skipped that color-codedness there, if we ran it, it would error out and tell us the same thing, right? Shape is abstract, cannot be instantiated, which is exactly what we want and what we did by design in terms of shape. Why? Because we know shape should never be instantiated. It has to be a subclass of shape, in this case like circle, that can go ahead and instantiate, right, this circle object. So just FYI, again, you have to have this method, right? Otherwise, if you don't implement calculate area on circle, because circle extends shape, it's going to give you an error here that says, hey, circle, the class circle must either be declared abstract or implement the abstract method. So what does that rule mean? That rule means that the first concrete implementation of an abstract class, right, has to implement those methods, those abstract methods. This could be abstract, and you can keep, furthering, throw the puck down the line type of thing, right? Just keep extending that. But the thing is, once you first hit a class that is not abstract and it's extending an abstract class, well, you better have those methods implemented. And that's what this means here. You're not going to get far without that. Lastly, I will say that as of late, Java version, I think it was Java 8, just like interfaces, you have the ability to create a default class to go along with this. And that would act just like a regular class method that we can just say test here, whatever. And then we can say something like, whatever, it's not going to return anything. Let's just print something. And we'll just say something here. And that's just to show you that this test here method will be inherited in circle, because circle extends shape. And so here we could always say, go ahead and say my shape dot notation test here. And if we ran that, we would know we can't do shape. It has to be circle. We talked about that. It has to be circle. But if we ran this, we'll know that test here will be inherited just like any other class. So abstract classes, they can have default methods or concrete methods, right? In addition to abstract classes. I hope this helps.